Welcome to RCR Wireless News. I'm Martha DeGrasse, and I'm joined by Scott Sumner. He is VP of Solutions Marketing at Accedian Networks. Scott, thanks for making the time. It's great to see you again.
Yes, thanks, Martha. It's great to be here.
We are talking about investing in HetNets, and we know that for operators, one of the big questions is always, how can I future-proof my investment? How can I make sure that the money I'm spending today will lead to solutions that can scale and that can adapt to new technologies? And I think that you've done some work in this area, and so I'd like to hear your thoughts here.
Yes, it's quite an emerging area, of course, as you know, and these areas in terms of growth of capacity and densification to meet people's expectations in terms of quality of experience are really leveraging the small cell and distributed antenna systems that can reach out to further points in the network and increase the bandwidth density available to users.
Right. Well, vendors talk about up to 18 months from the time a carrier signs on to deploy a small cell solution until the time of the actual deployment. And since you do so much with validation, testing, optimization, I think that you can give us some good information about what takes so long, really.
Yeah, I guess we hear the traditional issues at conferences and reading about it, about getting the proper site acquisition, getting the tower permits, getting the backhaul there itself is actually difficult sometimes, especially for distributed antennas where you need to have fiber. But more of the problems come from the procedures that are used. If an operator chooses to start with the procedures they're using to deploy and turn up a macro cell, they quickly find out that this isn't a scalable solution to all these tiny little endpoints out there, that really the ROI of the business case of small cells can't afford to have someone there for a full day doing a turn-up test or carrying very expensive test equipment. And these delay the rollout quite a bit as procedures are adapted or as they try to solve a problem of scale with tools that aren't designed for that.
Okay, now let's talk a little bit specifically about interference. I know that, do you think with small cells specifically, is most of the interference coming between small cells, or is it when they're indoor, or is it mostly small cells with the macro?
I think the macro cell interference is starting to become addressed by some of the solutions we're seeing. The small cell gateways are able now to detect someone coming into a building, for example, and keep them on the local network to prevent some sort of interference with the macro that may be reaching into the building. Of course, this is kind of complexified by 3G voice still being used instead of VoLTE, so you might have a handset in the building using a couple of carriers from different towers at the same time. That's not necessarily an interference scenario, but it can certainly wreak havoc in terms of watching the backhaul traffic and the quality of experience and how the control mechanisms respond to this kind of diversity of location.
Okay, and you mentioned backhaul. Now that's often the corporate LAN that supplies the initial backhaul, right?
Yeah, this is a problem I think for the service providers in general for indoor small cells is they don't always have control over the backhaul itself. They certainly don't have the last 100 meters or 100 yards to the desk or to the small cell antennas. That's kind of happening through the corporate LAN, and you have to hope that the IT staff can provision the proper quality of service to these locations without interfering with you. But the bigger problem is that if there's different offices or different branches, that some of them are going to be connected or backhauled over the open internet back to a peering location where the provider has their own private backhaul. And this kind of situation can really lead to a lot of performance degradation in terms of latency. If there's high congestion on the network, it could impact capacity. It's not as predictable as having your own connection, clearly, but the operator is still responsible for the service and the quality of the service, and the customer is going to associate any problems with their mobile provider. So they have to really think very, very carefully how they're going to monitor and assure and at least be able to detect problems quickly when it's not even inside their network.
Well, how can they do that?
Well, I guess an analogy to that would be how a lot of the larger service providers do off-net business services. So if you take level 3, for example, they'll have a very large footprint of on-network buildings, but they're going to need to reach branch offices and other, let's say, banks or different customer remote locations that aren't on their footprint. So they're going to wholesale the last mile in fiber or in radio or whatever it takes to get that extra last mile covered. but they have to make sure that they have the end-to-end responsibility of their SLA being met. So what they'll do is they'll provide some sort of small piece of instrumentation, either a smart SFP or some network interface device at the premise that's off-site and off-net, and they'll tunnel through it with testing to make sure that the end-to-end connection is still valid. And they're also going to segment that so they know when they go into the third-party wholesale network how the performance was on their side and how the performance is when it reaches a customer. So they can hold accountable these wholesale parties for another SLA that can keep them in check. Now, for the open internet, there's no SLA that's going to be made there, but at least the service provider can point out to the customer that the problem we're having with our service quality today is because your internet connection is just not up to the speed required.
Okay, and then that kind of leads to the Wi-Fi connections that may be also blamed for service problems. Somebody could be on a Wi-Fi network but not realize that it wasn't the carrier's problem if that went down.
Yeah.
Can you talk about that a little bit?
Yeah, that's actually a classic problem, not only for Wi-Fi, but also for any UE that's out there. If you're standing on a street corner and you're not getting good download speed, the question here is this a radio access network issue? Is this really interference in the street? Is there too much happening? Or is this actually the backhaul that's causing the trouble? So the Wi-Fi antenna in an enterprise may have serious backhaul issues, and the radio side might be working just fine. To do that, you have to be able to test both the air interface side as if you were an end user, and also be able to monitor the small cell, the backhaul connection itself, or the Wi-Fi access point itself. And there are some devices now that are very low cost that can actually monitor both of those from the same location. So the same device can monitor the air experience of the customer and also the backhaul connection, and then you can correlate what's going wrong.
Okay, now what are some of these devices that can do this?
There's a lot of different formats of the endpoints that can be used. I'll just call them modules for the term because they originally started out as smart SFPs that had embedded instrumentation in them, FPGAs that could be fit into a standard SFP format, plugged into a small cell gateway or a cell site router. But in the enterprise, there's a lot of copper connections, there's a lot of Cat5 cabling, so over time the endpoints have evolved to have different media conversion options, and electrical to electrical or optical to electrical, but the core functionality inside still remains this small programmable chip. And the reason these things are small and inexpensive is because network function virtualization can replace the CPU functions of these devices, so that can be centralized and hosted in a data center. And really, you're trying to find a way to get the minimum, least expensive piece of hardware out there that still has the precision to do these complex tests without having, a power supply requirements, racking requirements, and the cost of deployment. So that's really how instrumentation's evolved to address these many endpoints today.
And you're doing that with some of your solutions now, right?
Yeah, we were shipping this solution called the VCX controller for a little while now, and it's being deployed nationwide in a couple of operators for small cell monitoring here in the U.S. and also in Asia. And it's really a no-brainer for them. NFV can be complicated to a lot of operators, but the way we packaged it was to make sure it could be installed as a physical appliance as well as a virtual appliance, and that when you log into this, it appears the same from an operational perspective as a traditional standalone unit. So the same CLI commands, the same SNMP commands, the same integration into the NMS or OSS systems, and ultimately they're using the same procedures they would use for a macro cell turnup on a small cell, but now the customer can actually self-install these little modules, and they don't have to send a technician out there, and the cost of them is a fraction of what it used to be, up to 90% less in terms of hardware. So it really meets their needs in a way that we can see them working with us to develop the next level here. Okay,
great. Well, getting back to Wi-Fi for a minute, we hear so much now about voice over Wi-Fi, and I'm wondering what you're hearing from your customers and what operators are doing to try to prepare their networks for both voice over Wi-Fi and, of course, voice over LTE.
Yeah, that's a great topic. I mean, voice over Wi-Fi, probably what we're using right now, probably works a lot better than a lot of the VoLTE deployments we saw early on in Asia, where they started rolling them out in South Korea and Japan. And China as well had a lot of false starts on VoLTE. Many of those came around from the problem with synchronization and timing, because the requirements are just exceptionally tight. But there's also problems with packet loss and backhaul quality that you can sense when you're in the call. I guess the big problem is if you just have unreliable bandwidth, or the bandwidth is just on the edge when capacity increases of users, I should say, the call will just simply stop. It's not like a circuit switch voice call where the call may degrade in quality. It's really about it's on or it's off, and roaming between or handoffs between towers requires exceptionally tight precision. So what operators can do is they can simulate this kind of traffic very easily before they get into the situation where they commit to developing a region for VoLTE. They can load test their network, they can simulate the exact traffic types, they can simulate the MOS score of what calls will sound like, and that'll allow them to understand if there's some pinch points in the network that just aren't responding, address those primarily so that when they roll it out, they have the confidence day one they're not going to disappoint their subscribers.
Okay, great, great. This is great information. Now, for people who may not know what a MOS score is, can you explain what that is?
Sure, yeah, it's probably the least scientific of any metric out there. It stands for mean opinion score, and it was developed back in the 80s to develop for voice over IP quality assessments and also for auditory testing. But really what it is it was developed on a score of 1 to 5, I should say, 5 being the highest quality. And a voice call that we would expect would probably have a MOS score around 3.5, and an HD voice or a VoLTE call can get closer to a very close conversation between two people, so around 4.5. And this score was developed by people listening, thousands of people listening to the same sources of information, the same playback, and ranking it on the scale of 1 to 5 subjectively. And then the scientific models have emerged to kind of turn this into a quantifiable calculation that you can perform, and now it actually correlates very well with human experience. And you calculate this by using packet loss, delay, jitter, and other basic metrics, and you can estimate what the sound quality will be for any individual user with a high degree of accuracy now.
Right. Now, I know that most of us use our phones more for data than for voice now, but is it fair to say that in many cases voice is still the metric by which a lot of people judge their quality of service overall?
I would think so, and I mean it even more complex in a call that is a VoLTE call, or a call like we had earlier where I was attempting to use Skype as a voice mechanism. The problem with this, if you're in a bad situation, is that the voice call itself, even over over an IP or high bandwidth connection, is the first to reveal the flaws of bandwidth, latency, packet loss. All the metrics have to work together for that to work. So in the future, I think if you have a bad Skype call, you can be pretty sure that you're going to have a bad gaming experience. It's really the most difficult thing to pull off in a sustained way over a period of time.
Right. All right, Scott. Well, this has all been great information. Is there anything else that you want to make sure we know before we finish here?
I think yes, this is just the beginning, really. When you talk about virtual instrumentation, what's really exciting about the years ahead is that once people move their platforms for measurements and monitoring onto a virtual network function type basis with NFV, the development curve is going to be incredibly fast. It took us about 10 years to develop our products at Accedian for a hardware standalone appliance. It took about 10 months to reproduce that in an NFV-based environment. And you can imagine the kind of fertile development environment we're moving into now with people starting to realize what they can do with this upper layer analysis, packet capture, quality of experience, placing yourself virtually at somebody's location to see what they're seeing. These things are all now becoming possible, and it's going to be a great way for the quality of experience to keep up with the growth in traffic demand.
Great. Well, we always appreciate hearing from you. Scott Sumner, VP of Solutions Marketing at Accedian Networks. Thank you very much for your time today.
Yes, thank you. Thank you, Martha. Have a good day.